Now then, so we had rat tamers, now we've had Ed the worm lover, apparently, and now we move on to Rebecca Park. Rebecca, where is, oh, there you are, good. Rebecca, take the stage. Rebecca is Chair of Psychiatry at Oxford. She's an eating disorder specialist, a very distinguished and well-known one. She runs something called Oxbred, which is the Oxford Brain Body Research into Eating Disorders. How long did it take you to work out an acronym that gave you Oxford in the name of a food? Years? Just came to you in a flash. Okay, there is a correlation between having a very good acronym and the success of a clinical trial. It's actually been shown in the Lancet, genuinely. So, as you say, anorexia, the psychiatric disorder, the highest mortality of any disorder, and your particular skill is direct application from neuroscience to clinical trials and clinical interventions. So, the floor is yours. I will wave at you, so do try and keep an eye on me,
okay,
baby.
Okay. And the pointer is there. Yes. Hi, I'm Rebecca Park. It's lovely to overlap slightly with Ed again. I last saw him in Cambridge just before I completed my PhD in psychological process, had 5 kids and worked part-time in the NHS, and my work in anorexia grew from that. I will explain why in a minute. I set up a small research group when I was given a hefty clinical research fellowship, allowing me to buy out a bit of my NHS time and develop some academic interests. And all the work I'm presenting today is very much teamwork with the excellent neuroscientists, imaging people, and colleagues that I have in Oxford. Okay, so the motivation really was the awareness that the development of effective interventions is limited by our poor understanding of processes in eating disorders, and starting up an anorexia unit was a bit like treating schizophrenia without any drugs. Really biologically unwell people who we didn't have appropriate treatments for, so that inspired it. What I'm going to be talking about today is the multimodal imaging studies we've recently published, and a bit about the DBS trial that we've just started. I'll describe the scientific and clinical challenge of anorexia, how we rise to the challenge with translational neuroscience by defining disease processes and then trying to find novel treatments targeting those processes whilst integrating neuroethics. So anorexia nervosa, most of you will be familiar with the syndrome, very, very underweight people, severely debilitating with relentless self-starvation. Mean onset in adolescence, very low rates of recovery, particularly once entrenched, and the highest mortality of any psychiatric disorder. Most psychiatrists' nightmare. We're first described in the latter part of the 19th century, and it's thought to affect around 1% of females, around 1/3 of those of males, and has a 10 to 15% mortality rate, with chronicity in up to 50%, particularly those beyond adolescence, with no real effective therapies once people have been ill for 5 to 7 years, over 3 years, some would argue. The curious thing about anorexia nervosa is that individuals can maintain this extreme dietary restriction despite being extremely malnourished, and initially seem to get quite a lot of reward from that. It's characterized by a lot of obsessions and compulsions revolving around control of eating weight and shape, and an odd body image disturbance when people often perceive themselves as fat, even though when they're very emaciated. The importance of starvation in this syndrome is manifest in the observations of the Minnesota study of conscientious objectors in the Second World War, and they were systematically starved, and many became quite obsessional, preoccupied, and low in mood. So we know from this that starvation is important. There's a good pointer on here. Top one. Top one. Here? No, I'm doing it wrong. Sorry. Okay. That starvation itself is important. We can't treat the illness without being aware of the effects of starvation. But that dieting or weight loss can trigger these neurobiological and psychological issues which perpetuate the illness. And of course, many people diet and not everyone becomes anorexic. So there's something unusual about the effects of food restriction on people who develop the illness. In particular, we would argue that they have some sense of perverse or aberrant reward that sets in, which reinforces the need to control eating weight and shape. Sadly, the efficacy from drug trials and therapeutic interventions is really quite inadequate. Only about a third to half make a full recovery, and that's if they're caught early. And it's highly heritable, with gene linkage studies now suggesting some genes of large effect. And in fact, it's the only psychiatric disorder under investigation in the 1,000 Genomes Project, funded by Genomics England. So we need a better understanding of the psychobiological processes that cause and maintain anorexia to guide novel new treatments, which are sorely needed. It's a very expensive illness in terms of NHS costs as well as lives. And we've been developing a transdiagnostic model of compulsivity in the illness to try and think sideways about new ways of treating the disorder, and by defining and intervening in aberrant neural circuits. This represents the work of a colleague in the States, Walter Kay, and describes the development of the illness from predisposing traits, which are often things like perfectionism, negative emotionality, obsessive compulsive traits, and the illness being triggered often around pre-puberty for multifactorial reasons, possibly psychosocial, but also hormonal, genes that are switched on at that stage, and a period of dieting and weight loss, which seems to trigger neurobiological changes, which perpetuate a vicious cycle. Oh, sorry, I'm fiddling too much. So people enter this vicious cycle, and there's changes which are self-perpetuating, and some of them will recover, but others will remain ill. A popular schematic of the neuroscience behind this illness is described here in terms of, in a lay way, top-down or bottom-up processing, which is a term we don't really like too much, but just walking through this. A healthy person will be presented with food when they're hungry. Their mouth will water. They will feel they're hungry. Their somatosensory cortex will be aware of this hunger and links with the insula, and they will positively value the food, move towards it, and eat their lunch. Somebody with anorexia nervosa has faulty interoceptive signaling, often a large amount of top-down modulatory frontal control, and deficits in the communications between somatosensory cortex, such that they negatively appraise the food and they stay thin. So we've been exploring this compulsive aspect, and here are some quotes from my patients. Restriction felt good, it was a buzz. Now it's just a way of life and I can't give up. And this last said, you become addicted. Sticking to your rules is the most important thing. Trying to ignore the compulsions you feel is like trying to get a heroin addict to turn down heroin. It's near on impossible. And indeed, when we did a qualitative analysis of our patients, we found the themes that emerged very much mirror those seen in substance use disorder. The escalating compulsions, the triggers, the impaired control over those compulsions, the negative reactions to preventing them, the functional impairment, and carrying on doing it even though it's damaging. So we've written a theoretical account of this, which really it can be summarized here. And it's partly borrows from Trevor Robbins' work, really, about compulsivity as a transdiagnostic concept. We reviewed evidence that aberrantly rewarding behaviours over time become habitual and then compulsive in anorexia, and that's reinforced by starvation. We've seen that abnormalities in the activity and volume of the striatum, the limbic parts of the brain, and the frontal cortex occur across compulsive disorders, eating disorders, OCD, and addictions. And I guess we're suggesting that maybe dysfunction of cortical striatal circuits leading to aberrant reward processing could be common across compulsive disorders and could underpin some of the compulsivity seen in anorexia nervosa. Now, reward circuitry is quite well defined in animal and human studies. This is activation of the medial orbital frontal cortex to water when you're thirsty, monetary reward when you're poor, and pleasant music in the ventral striatum. Okay, so there's the striatal and frontal aspects of the reward systems. Now, we did an intriguing finding in anorexia nervosa, and this is from another group, but it's a lovely study, shows that in anorexia nervosa, individuals actually find thinness rewarding. So this is showing individuals who are underweight thin images, and the patients are activated in the opposite direction to controls. So that the illnesses, thin cues are rewarding. And intriguingly, this ventral striatal neural marker develops over time of illness, so people with a very short illness don't yet have this. But it does suggest there's something important about the striatum in this disorder. We subsequently did a taste fMRI paradigm using liquid chocolate in recovered individuals and found that individuals recovered from anorexia versus controls had hyperactive ventral striatal responses to chocolate taste, despite the fact they didn't overtly want the chocolate or like the chocolate anymore. By self-report, their brains were behaving differently. And conversely, with an aversive taste, their brains were hyperactive to the aversive taste, particularly in the areas of this sort of insular, the limbic system, and caudate. So we then sort of began to ask the question, well, the brain and what people are saying they like is kind of different, and borrowed from the work of Berridge, which makes a distinction with what you like, the pleasure aspect of reward, and what you want, which could be what you want overtly and consciously, or could be what your motivational motivations are, which aren't necessarily in concert with what you want. For example, if you are overweight, you might really want those chips, but consciously you don't want them, okay? So making this distinction is important, and we wanted to unpick this explicit-implicit differentiation, and adapted a food preference task specifically for anorexia nervosa, which is... okay, so these are the sort of explicit wanting, how much do you want this food right now, responses. In people with current anorexia, people weight restored but still ill, people recovered and healthy controls. And you can see that particularly in current anorexia nervosa, low-calorie food is preferred, which, if you are starving to death, is not biologically adaptive, right? But we then wanted to look a bit further to the sort of more implicit aspects of motivation towards food, and found that using a reaction time element, the more underweight and ill they were, the more motivated they were towards low-calorie food and away from high-calorie food, exactly the opposite to what's going to be biologically adaptive. More recently, we've adapted that food pictures task to look at the neural correlates of food reward in anorexia. And I'm going to be mentioning a fMRI study, a task-based fMRI study, a resting state fMRI study, and a Meg study, which we have done all using, well, not the resting state, but the task-based Meg and fMRI using food pictures. So with this fMRI task, then, there is a block design alternating high and low-calorie foods after a 4-hour fast, so people are standardly reasonably hungry. And I want to just summarize some of the results, because there's quite a lot of them. But I think there's two particular things I want to highlight. Firstly, in response to food versus no food, the somatosensory cortex is underactivated in those with anorexia nervosa. Okay, it's kind of asleep. It just doesn't respond. And secondly, intriguingly, the frontal pole, the higher order decision-making center, is activated in the opposite direction from controls to high-calorie food. Okay, so an individual with anorexia sees high-calorie food, and their frontal pole activates, hyperactivates in the opposite direction to somebody who is perfectly well. And we just found this was intriguing, particularly as it correlated with the severity of eating disorder preoccupations and rituals. Now, the frontal pole is suggested to be, the activity is thought to reflect process of accumulating evidence against doing the opposite, okay? So it's like a grass is greener. So the more you deliberate over whether you should do something or not and then do the opposite, the more activated your frontal pole. So this differentially increased signal to high-calorie foods in anorexia, we think may reflect this process of accumulating lots of evidence in favour of not eating. Whereas the reduced activity to low-calorie food just reflects the fact these are safe choices you don't even need to think about. And we wonder whether the frontal pole might be a novel neural target for non-invasive neuromodulation, which I thought was, I was fascinated by Carl's result about the cocaine addicts and the TMS. That could modulation promote more adaptive food choices or get people out of this sort of compulsive avoidance of food or compulsive addiction to starvation, whatever you choose to describe it as. I've mentioned also that somatosensory regions are reduced in activation to food, so that could reflect a sort of reduced feedback about body state, so people can effectively starve to death without noticing. What I haven't gone into is the PPI analyses, the connectivity analyses, which are also very interesting, but it would take me too long to go into those. So particularly there was reduced caudate connectivity with somatosensory regions. Okay. To move on then to resting state studies, I know there's some controversy about resting state studies. We've tried to do it as well as we could, really. But this is what the brain is supposed to be doing at rest, just ticking over. And we found two particularly interesting, or two significant findings in two networks. The firstly was decreased connectivity within the lateral visual network, which is here, in anorexia compared to controls. And this is temporal fusiform cortex. And this is a sort of body object recognition type area, which is quite intriguing given the body image distortion our patients have. And the second finding was reduced connectivity in the somatosensory cortices, rather parallel to what we found in the task. So we wonder whether this is consistent with a reduced interoceptive awareness and body image misperception characteristic of anorexia. And I have to say these abnormalities correlate with the intensity of compulsivity of the eating disorder rituals at its worst point. So it begs the question, this may be a scar of the illness or it may be a predisposing trait, and we can't address that with these studies. And then thirdly, we have published the first Meg study of anorexia worldwide, which is very preliminary, you know, but quite intriguing. The Meg data was acquired viewing the high and low calorie food pictures, and attention was assessed with reaction time and eye tracking. The time series analysis here suggests that around 150 milliseconds, that's really early, there's increased neural activity in response to any sort of food in those with anorexia nervosa, consistent with very enhanced early attentional bias cognitive control, maybe flagging food up as something to move away from. And the source analysis was intriguing as well because the frontal pole again came up as an area that was important. So this is very, very preliminary pointers towards future questions more than anything else, but it's intriguing, isn't it? Finding different facets of this illness and better understanding it bit by bit like a jigsaw. So I'm just sort of conjecturing here, but I've seen so many people so stuck in this illness. One wonders whether that early neural attention bias we see with Meg may enable avoidance of salient food stimuli that our patients are so very good at and enables them to maintain dietary restraint. This increased frontal pole activity could again be flagging up restraint very highly. And we see reduced activation of somatosensory regions in at least two of these studies, which could promote lack of awareness of thinness and abnormalities in body and object recognition areas, which could subserve body image distortion alongside this altered striatal activity, altered motivational salience of food, which seems to be associated with compulsivity. So what are the implications of this? Can we start to see anorexia as a disorder of connectivity, of which compulsivity is one element? So we've been thinking about translational approaches to treatment innovation. Now, I don't know how many of you are aware of the treatments we have for eating disorders, but they're largely psychological, and I don't for a moment want to diss psychological treatments. Psychological treatments are very important, but we need treatment strategies that act in novel ways and maybe not those that we think of. So, and these are more questions, I wonder whether the strategies need to work on these aberrant reward processing and obsessionality, such as training cognitive flexibility, reducing rituals, and training interoceptive and somatic awareness. But we may need to combine those with other ways of intervening with neural circuits more biologically, I would suggest. And here we're moving towards thinking about neuromodulation, brain stimulation, both non-invasive forms, the TMS we've heard about from Carl, the TDCS, maybe to cortical targets, such as the frontal pole. And then maybe for more entrenched illness, we need to think about more invasive strategies, even to deep targets, such as DBS. These are quite extreme measures in the latter. I'm going to talk a little bit about the DBS story now, because it remains controversial, I think. It's really very experimental for all psychiatric disorders, but particularly for anorexia nervosa, because DBS has got quite a neurosurgical interventions for psychiatric disorders have a troubled past, but have become much more sophisticated. And DBS is non-lesional, reversible, involving electrode insertion to specific neural targets, which are then repeatedly stimulated. Of course, this presupposes that you know what neural target you should be aiming for. But the important thing here is DBS is reversible. And it's been used for Parkinson's and movement disorders, and my colleague Tipu Aziz helped develop some of the targets for movement disorders for DBS, but using primate models. So we don't really have a primate model of anorexia nervosa. And it's now being used for treatment-resistant psychiatric disorders, OCD. I know Eileen Joyce, who's here, has been involved in that work at Queen's Square, which is fantastic, depressions and addictions too, with showing some benefit, particularly in the compulsive disorders. So why develop DBS for anorexia nervosa? Well, I don't know if any of you have been to an inpatient eating disorders unit, but it's full of a lot of very desperately unwell people who've been unwell for a long time, and there's quite a lot of hopelessness about. Now that's it.
My life with anorexia was really a living hell.
Kitchener's Kim Rollins spent more than 20 years battling anorexia. She tried everything to save herself, but nothing could help.
My mom has told me before that she was planning my funeral.
But today, all of that has changed. Rollins underwent deep brain stimulation, known as DBS, a revolutionary brain surgery pioneered at Toronto's Krembil Neuroscience Centre. It's given her a new lease on life.
This treatment can offer others hope. That's what it's offered me. It's taken me from before I had it, where it was basically certain death.
In these 6 patients, we found that we are able to place electrodes, deep brain stimulating electrodes in the brain. We are able to turn down areas of the brain that are abnormal in anorexia, and this in turn helps alleviate some of the associated anxiety and depression, and in some cases, in half the patients, was able to restore their weight.
While DBS has been used to help patients with other neurological...
Okay, so there's a big danger of sensationalizing this sort of thing, but these Toronto results are intriguing, and the Toronto group are ahead of the game in this respect, in that they've been using subcallosal singlet to treat anorexia nervosa. This is a mood regulatory target, so as one would expect, any changes might be mediated by changes in mood. And what they found, and they've just published in the Lancet Psychiatry a follow-up of a larger number of patients, but these slides are based on their initial report, and they found that in around half of patients there were initial mood and anxiety changes, which then led on to changes in weight, often because patients were better able to use treatments they'd found too aversive before. They also have reported some metabolic changes in line with the clinical changes, and dynamic structural changes that could be linked to functional outcomes. And this is a graph showing the change in Hamilton scores against hippocampal volume is quite a high correlation of 0.8. So I guess the study we've begun in Oxford, which is registered under clinical trials, it was inspired a little bit by this report, but we've chosen a different target given the evidence we have for compulsivity and aberrant food reward. We are using the nucleus accumbens, the anterior limb of the internal capsule, which is central for reward processing and has shown some therapeutic benefit, I believe, in OCD and addictions. We noted that study of ethical issues, We noted that studies of ethical issues was absent, so our protocol includes an integrated ethical study. Yeah. I'll just carry on talking. It includes an integrated ethical study and neuropsychology. Okay. Has anybody got any questions, actually, while we wait for this?
No, go ahead.
Because I'd much rather just, yeah? Has anybody got any burning questions?
Yes, it was a comment. Sorry, I'm Diane Gosler. I'm a solicitor.
Hi.
It was a comment that was made, and I don't know whether it was David. It's my way of coping. It's the only way I can feel good about myself.
Mm-hmm.
And I wondered, how did that make them feel good about themselves? Did they see themselves as becoming... I was wondering how that made them feel good about themselves. Did that make them feel less fat as they looked in the mirror, or was it a way of punishing themselves?
My experience with patients suggests it sort of differs by, sometimes it's sort of avoiding the negative, right, and sometimes it's actively positive.
That's what I think it's two sides of the
there
coin.
Can be both. Yeah, thanks. Oops, is it still broken? Yeah. How long are we likely to take to rescue this? Okay.
Hi. Fascinating talk, and I was sort of intrigued by the compulsivity element you mentioned around anorexia.
Mm-hmm.
Just wondering whether in your research where you're looking at the binge purge subtype and whether you're thinking of the compulsivity element as well, or you're looking at the more restrictive
It's a very good question. We've tried to stick as pure as possible because I think as Ed mentioned, there's huge comorbidity and variability. So our studies have all been on restrictive anorexia patients. We would like to understand that core bit of the illness first before trying to understand the binge purge. But that's in the second part. It's that one, yeah. So the Oxford studies are underway. We track neural change using Meg because you can't do MRI scans after, or at least in Oxford you can't, after you have a DBS stimulator in your head.
Do you remember which one?
Yes, sure, I'll get it.
Yeah?
And there's a protocol over 15 months. Can I start the slideshow? Okay, start the slideshow from current slide. Okay, sorry. Okay. Yes, targeting the anterior limb of the internal capsule, which I believe is one of the Queen Square OCD trial targets as well. Rechargeable devices, so they last for 10 years, and use Meg to track neural change. And we're really trying to establish safety and acceptability and feasibility rather than efficacy at this stage. And of course, map neural mechanisms and symptomatic change following DBS. Importantly, one of our aims is to integrate an ethical gold standard to sort of roll out worldwide to guide this type of work, because we feel it's so easy to exploit vulnerable patients with very invasive interventions. We've recruited 5 patients, 4 of whom have had their operations. This is what DBS, the anterior limb target, looks like. And the patients recruited are highly selective, motivated, intelligent, capacitous, but very low weight and very stuck. And they've tried everything else. So as you can see, there's a very high risk of sort of false hope for an experimental treatment, and how you manage that has been one of the most challenging aspects of this, taking part in this work. This is what the protocol looks like once, after a very extensive triaging process. Those that are deemed eligible will enter the study and have baseline measures, including an independent ethical assessment, and then be followed up post-operatively, optimizing the dose for 3 months, stabilizing the dose for 4 months, and then have a blind on-off period, and once the dose is stable, a double-blind on-off period so that we can see if there's any change in symptoms during that window. At the end of the protocol, they have the choice of whether they keep the stimulator in and get followed up, or whether it's removed. This is the gold standard framework we've just published last week. And this is important because there are so many issues to consider in these patients, and we felt it was very important that other centres did not start this type of work without really thinking about the complexities of work with these patients in particular, because they're so malnourished. But some implications for other psychiatric disorders, I would imagine, too. We don't want patients to be too desperate, such that if it doesn't help them, that they fall into a suicidal despair. We want them to be capacitous and consenting. We want them to show some ability to tolerate uncertainty, and we have to think forward about how we manage the study end. The ethics sub-study is integrated from the beginning, such that I can't fully recruit a patient until the independent ethicist colleague talks to them for quite a long time on their own without me. And then she will feed back to me and decide whether she's happy for them to move forward. She does a capacity assessment using a semi-structured tool, a MACAT-CR, and then will act as the patient and their family's advocate throughout the course of the study, with an optional post-research interview to explore the narrative experience and ethical questions raised by this sort of work, hoping to reflect and learn from this whole process by combining that ethicist as part of the team. So just running through this very briefly. Because it's in the public domain, I do get patients who will self-refer, and then I have to triage them very strongly. A number of desperate emails I get about this are sobering, and of course very few of those patients would actually be suitable. And I always need to link up with their clinical teams and their families and make sure they're very, very well supported to go in this sort of experimental and high-risk protocol. And then once I consent them initially, they have information both from the neurosurgical team and from myself, have a couple of weeks to consider that before initial consent. But it's only after that they see the ethicist and get interviewed. She has power of veto to say, I'm not comfortable for this person to enter. If they're judged to have capacity and be suitable, they can take part. But if they change their mind or want further advice, the ethicist can come back in and they can be withdrawn or withdraw themselves. And just briefly, this is the type of issues the gold standard framework covers. The importance of rigorously assessing individuals' need, their history, and their possible risks and benefit to them personally, considering issues of capacity and informed consent. And capacity can be quite complicated in anorexia nervosa because you can have somebody who seems very intelligent and rational about just about every other aspect of her life, but when it comes to decisions relating to her treatment, the choices are neither free nor very rational. So it's quite a skilled business. We always consider how well supported the person is, both by their clinical team and by their family, and who can advocate for them during the research so they don't get coerced into pleasing people, which is quite a common pattern in our patients. And we need to consider future care after the research participation, particularly if the individual chooses to keep the DBS stimulator in. The other issue is future public interest, and I would say also the publicity element. I always like to warn my patients that the media love to pounce on this sort of thing and that they could be unwittingly exposed if they're not careful, so I only talk to the press with purse strings around my mouth. This is very much multidisciplinary teamwork, and it's important to mention that the whole of the team taking part in this, Professor Aziz, the neurosurgeon in Oxford, his nursing colleagues and the neuropsychologist, myself and our postdoc Jessica Scaife, who also has been involved in all the imaging studies, and the imaging team at OBA, as well as the ethicists involved. With thanks also to the funding we've received, initial seed funding from an MRC Confidence in Concept Award to myself, donations from the Charles Wilson Charitable Trust, and from a grant from the Swiss Anorexia Foundation. Thank you for listening.
Thanks, Rebecca. You'll receive your application for the Society for the Abolition of PowerPoint straight after this. And thanks also to the Janis Joplin fan in the audience. Actually, Janis Joplin died of a drug overdose, as we know, but she also suffered from eating disorder. So perhaps it was a deliberate choice. So we'll take. You did take some questions as going along, but you're allowed 2 more then. Who would like to? Who would like? Yeah. Yeah, you do need a mic just because we're recording.
I'm Paul Shotwell from the Institute of Psychiatry.
Hi, Paul.
I'm very interested in the DBS study, and also the primary outcome measure presumably is increasing BMI. But what effect, if any, does DBS have on the other features of the illness, such as morbid fear of fatness and body image distortion?
Those are the questions we're going to be answering.
Because presumably if they persist, they could be worse for the patient.
Absolutely, absolutely. And actually there's a lot of work coming out of China, but none of it's properly published, and partly because they don't actually, well, A, they don't do all the ethics, but B, they choose adolescent girls and just do it. But thirdly, because, the complex aspects of the psychopathology need to be, you need to measure those very systematically, yeah.
At the back.
Hello, I'm Susan Mizzen, I'm the chair of the psychotherapy faculty. I wanted to talk about the relational aspects of anorexia as I treat a group of complex patients who have a mixture of PD and eating disorders. Probably rather different from your group.
Not really, no. But they're not the ones I choose for DBS.
Yeah. So the question I have is, I'm doing my own functional imaging study of that patient group, and I'm wanting to find a relational trigger for their anorexic symptoms, because what I observe is that in a relational context, the symptoms fluctuate with their proximity or distance from the people who they're relating to. So it seems to me that there may be a bidirectional causation between psychogenesis and neurogenesis.
Absolutely,
and
I wouldn't wish to, for a moment, to suggest that sort of psychosocial influences aren't important as well.
Sure,
yeah.
But I guess what would be a very interesting thing to develop would be a fully developed model in which we understand the genetic and relational and defensive contributions to what may be a sort of common final pathway in terms of symptom presentation. So I wondered what you thought about that.
Rebecca?
I think that's a huge and important question, but it's not going to be answered within my lifetime.
I love optimism. One more, just lady in front.
Hello, my name's Anne Cook. I'm from the British Neuroscience Association. Correct me if I'm wrong, but it's my understanding that quite a significant proportion of people who have anorexia nervosa, even the restrictive type, do actually go on to develop other eating disorders, so they can transition and become bulimic or even
they can, absolutely, yes.
What I'm interested is with the sort of direct manipulation of this brain circuitry, which affects, sort of reward circuitry and maybe some frontal control as well. whether that actually makes them more vulnerable to developing another eating disorder, or whether it actually helps them avoid that altogether.
Absolutely. These are exactly the questions. This is exactly why we're doing this sort of work.
Okay.
I believe from the Toronto group that there's at least one patient that actually didn't like having the DBS because it took away her anorexia. Yeah. These are really are, and it's partly why we've chosen people who are very stably restrictive over many years, and also have tried everything else, including all the psychological treatments. I mean, the previous question was really important. You know, there's a lot of psychosocial influence on any of our habits and mental states.
Okay, so what better way to go to lunch than with a talk on eating disorders? And Rebecca, thank you very much.
Thank you.